I'm Whitney Compton, and with me today is Lars Christensen, who will be leading the demonstration. Lars is a design and manufacturing expert who helps people that really hate struggling with their CAD and CAM software. He has extensive design and manufacturing knowledge, using CAD and CAM for managing, designing, and building complex parts. And he's shared his know-how around the country. He's been featured in manufacturing magazines, as well as influential online engineering sites, and he's excited to share some tips for getting up and running today. This brief introduction will be followed by Lars's demonstration. We'll have some time at the end for Q&A, so please feel free to post your questions to Lars on the GoToWebinar control panel. And I'll ask those on your behalf at the end of the webinar today. And if we don't get to your question, don't worry, we will definitely follow up with you after the webinar with those answers. So with that, I'm going to pass it to Lars to get started. Lars?
Thank you so much, Whitney. Hi, everybody. Thank you so much for joining us here today. Really appreciate you guys taking time out of your day to come here and see a little bit about Autodesk's HSM solutions. And we do have somewhat of an agenda, but we really don't want to be spending too much time inside of a PowerPoint here. If I am doing a decent job today, then you should feel pretty comfortable using the tools that we have available in regards to programming CAM. So really over the next 40 minutes, 45 minutes, I want to take you through a couple of scenarios inside of the software, showing you the steps you take to actually create toolpaths and how to get hold of the software, how to use it. And then again, as Whitney says, in the end, please put in, we'll answer your questions, make sure we get back to you. So please don't hesitate, just throw the questions in as we're getting along here. So I do want to get in and talk about why Autodesk is so heavily involved with manufacturing these days. But honestly, I think that we just want to jump into the software, and then we're going to cover these different bullet points as we're getting through. So I'm going to start inside of Inventor. So our solutions are running within 3 products. It's running inside of Inventor with Inventor HSM, and that's really the interface you're seeing here. So if you're familiar with Inventor, this will look very familiar. And we're also running inside SOLIDWORKS. And really, the reason we do that is because sometimes people don't get the opportunity to decide what software they got to use, and why not also have fully integrated CAM inside of SOLIDWORKS. And then kind of the new kid on the block, Fusion 360. And I'm going to go in and kind of show you in all 3 products the software in there. I just want to make a point, though, that the way we are attacking programming with CAM inside of the software is the same steps. So if you're using another product, you will see that the steps are the same as you're going through. So what we're looking at here is a part that is sitting in an assembly mode inside of Inventor. So the assembly, of course, is because we're having device here. We can see we have a table sitting here. And this is a really neat way to kind of work through with your part. You don't always have the chance to set it inside of a device. You don't have to, and I'll show you that. But I just really wanted to quickly take you through kind of the steps of creating toolpath inside of with the Autodesk HSM tools. So what we have up on top is we have a rhythm bar that is pretty, familiar to most CAD programs. And this is all the CAM tools that we need to be able to apply toolpaths within our CAD software. Over here, you will see that I right now have the assembly tree for Inventor with all our parts and models in it. So we can just switch over to the CAM tab, and we actually have a feature tree over here that will populate the same as you will do with your parts inside your CAD environment. So we have a plate sitting on a device. Let's just throw a quick toolpath on it here. I'm going to apply a facing operation to this part. So I'm really just going to go up and select a facing operation. And what you will see, we get populated with a dialog here over to the left. Now, what is really neat about this is that these dialogs are the same no matter what kind of toolpath you're using, and really no matter what software you're using. It's always the same. One of the reasons for that is that, not everybody gets to program 8 hours a day. If you're programming 8 hours a day as a CNC programmer, you might get very familiar with your CAM product, but many people have to kind of like maybe program for a few hours and then they don't come back to their software for maybe a couple of days or whatever. And if it's too difficult laid out, it can be difficult to get back in again. What we have done is that we have actually created this interface, and you'll see that goes through all 3 programs. It's the same 5 tabs up here. So as soon as, and I want to show you those today. So as soon as you're through those, you will always be able to remember where you're at. The first tab you always get presented with is to select the tool, because that's how you would do it out of the machine too. The first thing you will do is you will select the tool. So that's the first tab. So I'm going to go in here and select tool. And of course, I had that menu on another screen here. That's typical. And I'm going to give you a quick introduction to the tool library here in a second. But what we really have in here is a way we can install all the different tools. We can create our new tools. And I'm just going to select a 50mm face mill in here. So I'm just going to select. Now, the next tab you will see is the geometry. Now, when I click on that one, you will see that I kind of get a boundary, orange boundary box around our stock. One of the neat things about integrated CAM is that the software actually knows there's something there when it comes to solid modeling. So we're really taking advantage of that, because if you're going to face off a normal plate, normally you just want to face the whole thing off. And you will see by default, the software have already given you this alternative that you can just face the whole part off. You could go into stock selection, and I could select specific areas, and I'll do that later on in a few minutes here. But for facing, we normally just want to face off the entire part, and so I don't really have to select any geometry. So the first thing I did was I selected my tool path up here, and I selected a facing operation. Secondly, I selected my tool on the first tab, and that's really all I have to do to apply a facing operation in here. If I click OK, you will see that my tool path is selected. So that is about as easy as it can get when it comes to apply toolpath, inside of a CAM program. And as you will see as we're going through the different examples today, that this is how you approach every single tool, or every single toolpath inside the software. You select what kind of operation you want, you select the tool, and then you select your geometry, and then you're pretty much done. I can go up here to the Simulate button, and I would actually now be able to play through, and we can kind of see what we created with those couple of clicks there. You'll see I have like a little, I can speed up if I want to go a little bit faster. We can do that in here. We can also turn on the stock. So we can actually have it kind of like a stock display. So now if I play again, you can kind of like see that we are machining away the material. So you get this kind of feedback right in here, right inside of Inventor to apply these toolpaths. So it's very easy to do and get through this with a couple of button clicks. Now, what I did here was, so I created a facing operation just to kind of like touch off the top of my tool. I could actually go ahead right now and post that code out, send it to my machine, and have it start machining while I am continually programming on that part, right? So I can just go up here to the post-processing tab, and I can click on that one. And Inventor HSM is shipping with all these posts within it. And we offer a free version that is 2.5 axis. That was what I just used here. To do the facing operation, we can do pockets and holes. And it comes with all these posts. And we actually at Autodesk have a dedicated post team that will support you to get your generic post. So if we don't have a post on this list, then we will help create a generic post. So that's not a worry. That many times with other systems that can be a little bit of a worry. But with us, we have that covered. Now, so I'm just going to select whatever post I want to use here, and I can just go ahead and post this out. And when I do that, I will get this editor that comes along with Inventor HSM, and there you have the code. This is really what is important, right? The code is what matters. Everything else up to that point is really just a tool to get the code, because this is what the machine is going to be running. And of course, this code is fairly short because we're just doing a facing across the top of this part. But this is it. So with a few button clicks, we have actually created code here to post out to our machine. So I just want to show you how simple the steps really are to do this. Now, like I said before, I have this part sitting in a vise. And of course, you don't have to do that. I can just go in here and right-click, and I can open this part up as a part environment, so just one place. So a customer sends you a part and says, all right, so let's machine this part, and maybe you decide not to put it up in a vise, not to have it in assembly. One of the things that I want to make sure to say is that the steps are the same if you are in part or assembly. There's no difference. The steps will be the exact same. Now, one of the things we do have to do with CAM software is we have to do a setup. We have to tell the software what kind of stock we're using, where our pickup points are, 0 points. And if you use all the CAM products, that's many times actually the hardest thing, to tell the CAM software how things are sitting out of the machine. So I want to show you that here with this part here, really the beginning steps on how to do that. Fairly easy. You just go into the setup. So you always start out with a setup. This is where we tell how things are sitting out in the machine. And when we do that, whenever you get these dialog boxes, do yourself a favor, just start from the top and work your way down. That's kind of like the easiest thing. So this is a milling operation, but of course we also support turning and mill turn. And then the next one is where we can set our working coordinate system. This is what out of the machine, by default, many machines is called G54. So this is where we're going to pick up the part. And you will see that I kind of over to the right over here, I have like this 3D gnomon or triad over here. This is what indicates what is up and down on our machine. Now, if you don't model up the parts yourself, or you're getting them from like the engineering department, you will find that many times they will model things up that is upside down, flipped around, on the side. It's really not a big concern for us in the CAM, because it's very easy to change this organ and have it display the way you want it. So I'm going to show you that over here. Over here, you will see if I click on this orientation, you get some different options in here to how you can place that gnomon. I'll tell you right now, personally, I only use one, and that is the first one that is called Select Z-axis, Plane, and X-axis, meaning that we're going to select the C-axis and the X-axis direction to set the gnomon. So if anything you get out of this, this is what I use probably 99.9% of the time. So I'm just going to select that, and what I will do is I will first establish our Z direction. So on a vertical mill, it's up and down. And all you do is you just select right on the model, and whatever you select on, if I select on this top face, you will see that the Z-axis will go perpendicular to that face. So if I'm clicking here right now on the face, you will see that the triad over here is going to change the direction. See that? So now the Z-axis is now pointing up, so like if we're sitting in a vertical axis. So that is just done right out of the gate when you select this Z-axis here. Now, if I want to move the X-axis, so the X-axis, if I want to turn that 90 degrees so it's actually running the way the Y-axis is right now, it's really simple too. I just go over and I click on the X-axis, and now I can just select either a face or an add. So if I select this add, you will see that the X-axis is going to change. You see that? So now the X-axis have been moved. So that's really all it takes to move around how things are on a machine, is literally just going in and selecting under the work coordinate system. Like I said, I always use select Z-axis and then the plane and X-axis, and then literally just selecting what you want the X-axis to be perpendicular to, and then how you want to control the other axis. So very simple to do, right? Now this gray dot here is going to be assembling where our G54 is, and I don't want it to be here. Well, just continually moving down the menus over here to the left, you will see that I have different options on how do I want to set that. And if I select the start point, you will actually see that I get like small dots right now on our screen. And this really depends on how you pick things up out on your machine. If you are a mold maker, for example, they like to work from the center of a part, then I might just go over and select the center dot right there, and you can see how the triad goes right over to that corner right away. If I'm a tool and die maker, they normally like to work from a corner, so I might just go over and I'm just selecting right on these dots, and I have placed that point right there. That's really all it takes to set up where I'm not picking up the part. It's just a couple of clicks, and you can place this. If you see inside, so I use the stop box point, but you will see in here you can also select the module origin, you can select selected points, right? So you can literally go in here and select anywhere on a vertex, on edge, on your part. Now the next tab up here is your stock. And you get different options again in here, but these dialogues are always the same. So when you went through them once, you are really, you're good to go. I in here have something called relative size stock. That means that I can add some additional stock to all the different sizes of my block. I also like to point out that there's, again, a lot of different options. I like to point out that there is also from solid in here. So if you have your stock modeled up inside of Inventor, Fusion, or SOLIDWORKS, you can actually use that option too. This is great if you do castings or if you're part of it in another operation. I'm just going to leave it at the relative size stock as a default. But this is all the steps you have to do to tell the CAM software what you have out of the machine. So just to recap, start from the top, work your way down, select your operation type, select the Z-axis and the X-axis, and then you literally just select right on that model where you want to machine. And then you can go over and select with origin right on the model where you're going to pick up the part out of the machine, where your T54, T55 is going to be. And then, of course, like I just showed, the second one is stop. That's all we have to do to tell the CAM software where things are with the machine. So now we can apply our tool. So just like I did before, many times when you're machining something like this, you will do a facing operation. So let's recap that. So I'm going to click on the facing operation. Like I said before, the first tab is always your tool. So I'm just going to go in here and click on that. And now I'm going to give you a quick tour of this library here. So the tool library is pretty simple to use. Right down at the bottom, you can create new tools if you want to. You can create new tool holders. Like I said before, we also have turning tools. And then you have these edit and select buttons that you can use when we're applying tools that you will see are going to be inside of the area in here. Over here to the left, you have current what ships with the product of all different kinds of tools and tool holders and sample tools in all different types in here. And this is all the one that comes with the program. But you can, of course, create your own, or you can modify it. So let me click on the tutorial one here, and you will see that face mill I used before. So there's some information in here for this. Now I can go in and I can edit that. So if I click on that, you will see here that we get some extra tabs. And here's a really, really nice view over this face mill. So let's say that your face mill is not 50. Maybe it is 55. Then you can go in here and you can change it in here, and you can save it back to your library, and now you're set, as you're going along. The same thing if you have specific feet and speeds, you can apply all these in here. So all these options are available right inside of this tool dialog. Like I did before with the facing operation, you really don't have to pick anything else because the software already knows where the boundaries of a part is. So all we have to do is facing the part up. We select the facing operation, we select the tool, and that's all we have to do to apply a facing operation. And again, if I go up and hit the simulate, we can now go in here and we can take a quick look, and we can see that we are facing off the part just like we want. And again, if we want to, and I've surely done this many times, you will post this out, create the code so you can get it out to the machine. It can start roughing out while you continue programming. Now, if we want to continue programming on this part, I can go in here and, for example, there's these pockets here. So let me go in and machine these 4 pockets. Now I'm going to use something called adaptive clearing. Adaptive clearing is a really neat technology that will use a constant chip load on your cutter. Now, for some people, it's referred to as a roughing toolpath. I really don't like that, because if you come to me and you say it's a roughing toolpath, I'm thinking about removing a lot of material fast, and many of us don't do that type of machining. So maybe you're like, nah, I don't do that. But adaptive is really so much more than just a roughing toolpath, because what it does is it keeps a constant chip load on your cutter, what actually gives you less tool wear and less machine wear. So if you are an experienced machinist, a CNC programmer, I say that you definitely try to check it out, because I was really excited when I actually got to test it out in the beginning. And if you're new to machining, I would say just take my word for it and go with it, because it's great. I'm going to use another tool for that. So I'm going to go back in and hit the tool button on our menu here. And I'm just going to go down and select a 16mm flat end mill. If I go ahead and hit edit here and go over to the cutter, you can kind of like see that we're now using more like a standard flat end mill that could, by the way, be used for facing if you don't have a bigger face mill, right? I'm just going to select this cutter here. Now, in this case, I am going to select geometry. So I'm going to go to the second tab because I want to just specify the parts that I want to machine. Now, what I'm going to do here is I'm going to select inside of our geometry here, right on our model. And it's important that I point that out, because what I'm actually doing is I'm associating the tool path to that 3D model that we got in Inventor. What that means is that when we're now applying our tool path, the CAM software is associating the tool to that face ID in that 3D model. That is pretty awesome. The reason that is that if there's ever a change to these pockets, I don't know if I've ever machined something that didn't have a change to it, if the pockets get deeper or if the size changes, then our CAM software will actually flag us, and it will give us let us update the tool path, and it will just automatically update. I have had experiences, machining where when somebody said that there was a change, you really just started all over because you couldn't trust, the model anymore. In this case, because we're integrated, because we're working right on that CAD model, whatever changes, we can go ahead and we can use that. Now, there's other options in here. So if I go to the second tab was the geometry. This is where you always are selecting what you're going to be machining. The third tab is our heights. This is where we can select things like how are we going to wrap it around our part, and also how deep do we want to machine. So you see there's a lot of different options in here. You can say that we are selecting, in this case, I'm just going to the bottom of the contour that I selected, but it could also have been to the bottom of the part, things like that. So we have all the flexibility that you want inside of any powerful CAM, and it comes on top of these nice descriptions where you can see what's going on. The next tab, the fourth tab, is the passes tab. This has everything to do with the tool involved in the material. And what you will see here is that automatically it actually has a start to leave turned on. So I'm leaving a little bit of material in these pockets for me to go later up and clean up. Many times you will do that. You will rough out the pockets and then you will finish them up. So automatically that is turned on. But of course you can control all that right here with checkboxes and so forth. The last and fifth tab is what we call the linking tab. That has everything to do with the tool approaching the part or not being involved with the part. So this is where we can do all the rapid moves, how we are leading in and leading out, and so forth. So that's really the quick explanation. But what I did here was I selected the tool, and I selected the 4 pockets. So let me just go ahead here and hit OK. And many times when you're programming inside with this kind of software, what I recommend people to do is just go ahead, hit OK, and see what you get. Because you can always go in and change it again, right? So you will see that I now have created this adaptive toolpath. So if I go back again and click on the setup and going to go in and simulate, we can again see where we are along this this path. So here we have the facing operation, and then we have these adaptive roughing out these pockets here. So you can constantly verify and see where things are going, what you have machined. Another thing I want to point out is that there is down here a checkbox to show part comparison. If you turn that on, now you're actually comparing with what we have machined versus what that is left. So you will see that the top is gray because I finished that one off. But remember that I left some material. I had some stock to leave on those roughing pockets. So you'll see that they actually still blue, plus all the other stuff. So you get this kind of feedback right in here to do this kind of stuff. Talking about feedback, I think another thing that is really important to just show here is that if I wanted to machine around this part here, I could use something like a contour toolpath. So I'm going to select that. And I could use the same tool to do this. So let me just do that. But one of the things I'm going to do to this tool is I'm actually going to go in and edit it. And I'm just going to go in and change my flute length to something very, very small. So if I do like 10 millimeters, and I hope that nobody have any tools that looks like this, that it's short, any regrounds laying around. But I really only now have a flute and shoulder length of 10 millimeters, which is very short. Just going to update that. If I go in and select to machine around the outside of this part here, and I'm just going to hit OK, you will see that I get a toolpath that goes all the way around the bottom of our part. Well, and you will actually see that since I updated the tool, the adaptive above is actually now giving it a little red X, because it has realized that we changed the depth or the tool length, the flute length of that tool. So it's actually giving us a warning saying, hang on, this toolpath might not be up to date. But what I want to show you is that if I go in now and hit simulate, you will actually see that down at the bottom of our simulation, we hope this shows, we have like these couple red areas here. And this is because the software noticed that since we only have very little flute length, we are actually going to have an issue machining all around this part. And you will also see that when I hit the play button here, that our tool is actually going to turn red, right? It gives us a notification back that that this is not good. And the reason for that is because I changed the flute length on this tool. So you can get this feedback right here that there is an issue. Now, if I go back in again and I change that tool back to where we were before, I messed with it. So let's go ahead and edit it. And I think that this was 55. We just need that 55. Let's go ahead and select that. And then update that. You will now see that when I go in and simulate it now, because we now have that longer flute length, we don't get any warnings anymore. Now the tool can pass around. So this feedback, I mean, this is critical when you're programming. You're sitting there, you're programming your part. There's so many things to keep track of, beats and speeds and all this stuff. And that the software gives you this kind of feedback, I think is really, really helpful. It actually also can do that, and I'm not going to show it right now because I want to show you other parts of the software. But as I was inside of our assembly before, I could actually also say avoid these fixtures here. So right inside of our setup, there is actually a fixture button, and I can actually select these jaws on my vise, and it will also give me notification back if I hit those. So we do have that kind of information in there. So I hope that this is really helpful, just kind of like seeing the step through, you know, you create your setup where we selected where we're going to pick up the part, and then really just stepping through how to create different portions. Now, all the things that I've shown up to this point is all in the free HSM Express, Inventor HSM Express that you can go out and download right now. If you go to camp.autodesk.com, you can download that. If you have a seat of Inventor, you're up and running. And it's not a 30-day trial. It's a free 2.5-axis cam for you to use. And you can do all the stuff that I just have showed you up to this point. We also do have 3-axis, and I just wanted to quickly just give you a little idea about that, because that's one of the things that I used to do quite a bit. And actually, using CAM, have had a little bit of trouble when you get into what is called 3-axis, swoopy surfaces. So here I have another part sitting in another vise, another brand of vise, doesn't really matter. But what I've done to this little part here is that I've already programmed a little facing operation. I've already drilled some holes, and then I have already machined around it to kind of like rough it out. Why don't I just show you really what I did here, mine as well, right? So I used not a facing operation here, but I used the facing operation, but just with a normal end mill. Drill some holes, and then I kind of like roughed out the part so we can put a 3D surface on it. Now, the reason I wanted to show you this is because if any of you venture into this, this, like I said, with other CAM software I've used, was really a struggle for me to try to find out how to do that. Inside of our software, we have a lot of great 3-axis toolpaths that you can use. And being an old mold maker myself, I probably just pick something like a parallel toolpath here to just kind of like going back and forth. I'm just going to select that. Now, again, this is 3-axis, but you will see that the 5 tabs are still always the same. So I'm going to first go in and select a tool. And for something like this, you probably want to use like a ball and mill. So I'm going to select that. Now, the next thing I'm going to do is I'm going to select what I'm going to machine here. And you really have some great options to do that. Now, one of the things I know is I do not want to machine these holes that I've already drilled. I kind of like want the software to stay away from that. So all I have to do is to go in and hit avoid the area, and really just select, again, right on that 3D model that we got from the engineering department, or that you modeled up. And I'm just selecting those areas to say stay away from those areas. Next one was our height tab. I actually just kind of leave that one alone. This probably might be pretty good. You know, it's going to change things. The patches tab. One thing I see in here is maybe I want to do a little bit finer step over, so I'm going to change this to 1 millimeter. And then I actually just want to see what I get here. So let me just hit OK. And within seconds, we can actually get a tool path. I just got to go in here and make sure that I actually select what we want here. Let's go here. Oh, that's great. All right, so I'm missing something. So we selected our tool. It's always good when you do these live, because that's when you get tested, right? I was just telling you how easy it is. Let's just get rid of this. Maybe I selected something else. Shouldn't select them here. All right, so there's the full tool path, as I would assume. So I think I selected something wrong inside of. I think that we had some user error in here. Maybe I need to zoom in a little so I can see what I'm doing. Try that. All right. So here, I am now avoiding, you can see here, with the holes here, you can see that I'm avoiding those areas. You'll also see that I'm kind of like machining past it here. So I can actually also just right-click and I can go in and I can edit that. So you have, probably want to do like to the center of the boundary. I would think it's probably the default anyways. So there we go. So it's very easy to go actually in here, go back and forth and figure out. So that was me selected the wrong place to stay away. I think I said stay away from the whole thing. So it's very easy to go in here and apply these toolpaths. And like you saw here, if you want to change something, all you do is you just right-click and you hit edit. And then you can go in and change it. So if I want to go in and change the direction of my cut, I can just go in and change it to like 90 degrees, and you will now see that the cut is going the other way. So these steps are extremely easy to do, these 3-axis in here, as long as you make sure you select the right things. So that is extremely easy to use. Another thing I wanted to show is, even if you take it kind of like a step further, and I used to do a lot of this type of machining, where you kind of like have a tombstone sitting on a 4-axis, and you want to apply those same toolpaths. So what I really have here is I have the same part you just saw me program. I have it sitting here in dual vices, and I have actually also 4 other ones on the other side. I've already programmed the same toolpath that you just saw me apply to one of them here. If you're familiar with CAD, you're going to love this. I can actually just go in here and highlight all my tools for that one part that I programmed. And I can right-click, and I can go in and say I want to create a new pattern. And if you're familiar with pattern inside of CAD, it's the same principle. You can do linear patterns, circular patterns. You can do component patterns. That means that now the software is actually looking at your model and say, all right, if I'm selecting this one as my source, I can now figure out what the other part needs to be machined. I can control how I want my tools to be ordered. But what I have now is I programmed one part, and I actually now have programmed all 8 here. So you will see that my toolpath is actually now going to machine the one, but it's actually also going to machine all the parts sitting on the toolpath or on the tombstone. So you really have an option to do this kind of work. And what is really great about this, one of my favorite things about this type of setup, is that now you can have in your CAD system exactly what is out on the machine if you model it up. And what you're machining in here is what you're going to see out of the machine. So that's really nice. So I just want to kind of like show you this environment in here. Now, if I jump over to, let's just close out of this. If I jump over to something like SOLIDWORKS, so now we're inside of a completely different CAD system, and I actually just decided to throw in a turning part, because like I said, we do that too. But I wanted to show you that the principles are the same, no matter what software you're using. If you're using Inventor, if you're using SOLIDWORKS, if you're using Fusion 360, it's the same type of part. So I have this turning part here sitting. This is actually out of the DEC Mono racing car. This is part of the quick release for the steering wheel. And if I just want to go ahead and apply a profile toolpath to this, I can go up to the turning, and I will click on the turning profile. And you will see that, again, I get 5 tabs up here, and they mean the same. Even though that we're in a different type of software, even though that we're using a different type of machines, we're using turn instead of milling, it's still, the first tab is still the tool that comes up. I can select that, and I can go in and select whatever tool I want to do. And again, in here, we, of course, have all the options when it comes to, what kind of tool bits are you using, holder setup, how is it set up on the machine, all that stuff is the same. The second tab here is where you can do your contours. What are you going to select? Here we can also select things. Now, for this case here, I'm just going to hit the green check mark and say OK. And you will actually see that we have a turning toolpath right here on this part. And again, you will see this actually has it's going to have like a profile cutout here. So right now, I actually let the tool kind of like groove in the back. That is, again, all the options you would expect inside of a full-blown CAM system we have in here. If I go to the Passive tab, I can turn off Allow Grooving, and now you will see that that area has now gone straight over here for when we're doing that portion of it. And again, just like showed before, we have the simulation in here. We can go in, we can take a look at our toolpath, and you can get a good idea about where what we're machining in here. Also, I know I'm running out of time because I get so excited and just want to talk about this stuff. I also wanted to show you that we also do 5-axis in here. So again, this is inside SOLIDWORKS. This is actually a really, really nice setup. I think probably one of the better 5-axis setups that I have seen. It's pretty cool. These parts here, and we do that. We have a multi-axis operations in here, such as swap, tool path, and flow, multi-axis. So we do also support up to 5-axis machining. And again, if you have a setup like this is the CAD model. These parts here are actually the ones that we got from the engineering department. We can machine directly to those parts, and we can have the true, how the machine looks. We can have that inside of it. Last thing I want to show you too is Fusion 360. So like I said, this is kind of like the latest that comes out of Autodesk when it comes to CAD. Now the CAM portion though is still HSM. So everything I just showed you inside of Inventor HSM and what you show you inside of SOLIDWORKS is the same in here. So it's again the same principle. It's kind of like the same menus in here inside of Fusion. So you will again create the setup where you say what you're gonna, what your G54 is going to be, or your 0 point. You will define your stuff, and then you will go in here and you can go up to the 2D area and you can apply what kind of tool path you want. So again, you can select the facing operation, and in this case here the menu is to the right, but it's still kind of like the same 5 tabs, right? The first thing we always do is we can select our tools. I can hit select here, and I will get a menu up here. Oops. And here I'll have my face node over here. So I can select that face node. I can click OK. And then again, because it's a facing operation, I really don't have to go in and select any geometry. It knows it's there. But we have all the options to select the heights, the passive tab, that have anything to do with being inside of the cut, and the linking here to go out and do the tool path. So again, the same steps, no matter what you're doing in here, it's the same steps. You're building out, you know, your feature tree. We can apply the adaptive clearing like we did before. You can go and select your tool. It's like 16mm flat inlet I used before. And again, we can go into the geometry tab, always where we select what we're going to machine, and we can select that edge for machining. And you can control that and apply those tool paths there. So I really hope that in these 40 minutes, and I know there's some good questions, I'm looking forward to answering these, but I really hope that I've given you kind of like an insight through the steps when it comes to creating inside of really all 3 products. It's really just about going in and setting up that setup and pick up what you're going to machine, set up your work coordinate system, how you want the z-axis, the x-axis direction, and then go in here and apply your tool path. Start from the top, work your way down, and it's always those 5 tabs. So you always just work with first selecting the tool, then what you're going to machine, then you can select the depth you want to go to. So if it was a drilling operation, maybe you want to drill a little bit deeper than the material. Then it's the passes tab, the 4th tab, has everything to do with the cutter engaged with the material. So step overs, if you want to do multiple depth of cuts, and then the last one is the linking. So, you know, lead in, lead out, and that kind of stuff. So I hope that you guys kind of like found this helpful to sit through this and kind of like see how we have to offer this. And I kind of like abandoned the PowerPoint and rather wanted to show you you know, how you can go through that. So we really think that we have a solution here that is really great, integrated right inside of our Inventor, SOLIDWORKS, or Fusion 360. It's truly integrated CAM. You're exchanging anything on your model, you will see your tool path will get flagged, and you can update them right there. And it's easy to use. It's the same steps you're going through no matter what you're doing. And if you go to cam.autodesk.com, that is where you can download the 2.5 axis that is free for Inventor and for SOLIDWORKS, and up to our 5 axis solutions that are also including turning and so forth. So with that, I am going to, I saw some questions coming in, so I definitely want to attack some of those. Whitney, do you have those all lined up?
Yes, I do have a few questions lined up for you. Of course, the most common and most popular is the pricing question. what do your products, or what does this cost?
Oh, so that's important, right? So I talked about, now I gotta go out here, and I hadn't even opened up my website here. So let's go to cam.autodesk.com here, and you will see here that we have, if you go out to cam.autodesk.com, you will see that we have, you know, some great information out here. If you go over to Try and Buy, and you click on that, you will see that there's 3 tabs. So the first one is 2.5x, and you will see here that it is available for free. Okay, but if you have a seat of Inventor, then you can go out here and you can download this program right now, and you can be running CAM. If you same thing for SOLIDWORKS, if you have SOLIDWORKS, you can go and download HSM Express, and it's free to go ahead and use. And again, it's not a trial. It's literally, you know, we're just providing that software for free. For Fusion, there's some different, and I gotta watch out here because I might not have been completely relevant this till this point today, but there's some different options out there depending on where you are if you're a machine shop, if you are in different levels. So definitely go out there and check that out on cam.autodesk.com. For free access, you can see the prices right here. We post them right on our website. This is not, you know, wheel and deal kind of thing. I will point out that if you, with Inventor HSM, it actually comes with a seat of Inventor. So you don't have to go out and buy a separate seat of Inventor. So that is definitely pretty hot. And then, of course, the 5-axis in here, too, you will see that it's available here. And I want to point out one of the things that some of you may be not aware of is the desktop subscription is really where we're headed. So now you can just pay per month. We're actually ending the perpetual license where you buy the software and you kind of like buy the software and now you're using that software. In this case here, you actually subscribe instead, just like Amazon or Adobe and all the products you're using too. So cam.autodesk.com is the place to go and get the pricing.
Great, thanks. The next question I believe you just answered was how to activate it within Inventor, but it looks like you can download it from that Try Buy button.
Yes.
And then, oh, great. Go ahead.
Yeah, you're absolutely right. So if you just have Inventor, you will have to go out to cam.autodesk.com. So there's a link I have right there. And you can literally just, the easiest is just go to Try and Buy, and then you're good to go.
Great. So the next question is, are there any visuals that show that the coolant is on in the library or in the operation?
No. Well, there is inside of the software. You can control the coolant inside of this. You know, I'm going to leave the other one up so just people can see it if they missed it before. cam.autodesk.com. You can control it in there. You can turn it on and off. What coolant is normally, and I don't want to get too technical, but that is an M code, so a miscellaneous code. For most machines, is an M08, but it could actually be something different. So the software, you can turn coolant on and off inside of your operation, but it is actually controlled with what is called an M code normally, at least 99% of the time out of your machine, and those M codes can be customized from machine to machine. So we cannot just tie it in to, for example, M08 because it could be something different on another machine. But there is a lot of options to customize your post. So we might be able to do some fancy stuff with the coolant. But in regards to what I think you're trying to say is to actually show it in when you simulate, no. But that's because, again, because it's one of these miscellaneous codes.
Great. So it looks like we have a lot more detailed questions. So I think it'd be best if we followed up directly with you guys after this webinar. But the one question that we can wrap up with is this video going to be available for download at a later time? And the answer is yes. We have recorded the session, so we will make sure to send it out to all of you after the session. But Lars, is there anything you wanted to say to wrap up, or?
No, absolutely. I'm totally. Thank you so much for everybody to attend. I really appreciate it, and you know, I hope you really got something out of this. Your questions, we'll definitely make sure. I'm looking forward to get those and make sure to connect with you guys and answer all your questions. Sure. So, yeah, absolutely. Thank you so much.
Great. Thanks, Lars. Thanks, everyone. Have a good day.